Hey everyone, this is our last installment of Chapter 5, Section 3, Part 3. It's a doozy. We're talking about tree diagrams, so let's dive right in. In January of 2010, the Kaiser Family Foundation released a study about the influence of media in the lives of young people ages 8 through 18. In the study, 17% of the youth were classified as light media users, 62% were classified as moderate media users, and 21% were classified as heavy media users. Of the light users who responded, 74% described their grades as good, while only 68% of the moderate users and 52% of the heavy users described their grades as good. According to this study, what percent of young people ages 8 to 18 describe their grades as good? So we're going to make a tree diagram for this. When you're making your tree diagram, you can either go from left to right, or you could go from top to bottom. You'll typically see it go from left to right, so that's the way that I'm going to show you how to set it up. Now, tree diagrams are helpful when there's multiple things happening, right? So not only are we talking about the level of media use, but we're also talking about how they describe their grades. So to start with, a person can either have a classification as a light media user, a moderate media user, or a heavy media user. And then from there, we talk about how they describe their grades. So they're either going to describe it as good, or we're just going to say not good. So we've either got good or not good, good or not good. Now, we want to know, the question here is what percent describe their grades as good. There are 3 different ways you could say you have good grades depending on your level of media usage. So what we're going to do is we're going to fill in some of these probabilities, and we're going to do some basic multiplying. So for light, 62%. So I'm going to put a little 0.62 here. So saying there's a 62% of chance of that happening. There's a 21 or 0.21% chance for, nope, messed that up. It helps if you read the right numbers. 17% were light. So I'll use pencil. And 62% were moderate. And 21% were heavy. There we go. And since there's only 3 options, these 3 options should then add up to 1, right? 100%. Now for these little lines, it said of the light users, 74% describe their grades as good. So given that they're a light user, we've got 74% there, which would make this 26% for that one. We had 68% for moderate. So that's going to be, excuse me, 0.32. And we have 52% here, which makes it 48% there. Okay. So to figure out these 3, let's go ahead and multiply them. So I'll do 0.17 times 0.74. I'll do 0.62 times 0.68. And I'll do 0.21 times 0.52. So we get our values. So these values represent different ways of being good, right? So light and good is this, moderate and good is this, heavy and good is this. But we want to know just the chance that they describe their grades as good. So what we're going to do is we're going to take these 3 values and we're going to add them together. Okay? And we're going to get, we got 0.6566. So about 66% of young people ages 8 to 18 describe their grades as good. Alright, let's do another tree diagram. We want to represent this situation. It's kind of hard because I didn't print this very well. we need to, what is the situation here? Well, we're talking about picking 2 randomly selected students. So this is a little bit different than the last one because we're looking at number totals as opposed to percentages, but that's okay because we're just going to turn that into fractions, okay? Fractions as far as probability instead of decimals. So we're picking 2 students, and we want to know the chance that they will both have allergies. So first we need to pick one person, and either they have allergies or they don't. Okay. Then we pick the second person, and either they have allergies or they don't. Same deal here. And then we fill in our probabilities just like before. Now, how many people had allergies? 18 people had allergies out of 40. So this is 18 out of 40 chance of getting someone with allergies. And then you have a 22 out of 40 chance of picking someone without allergies. Now here's where it gets a little trickier. Say I pick somebody with allergies. The chance that I pick another person with allergies, after I've already picked one, that means there's only a 17 out of 39 chance, because there's one fewer person from each of these options. Now the chance that I pick someone that doesn't have allergies, there's still 22 of those, but again, only 39 people remaining. To pick someone with allergies after I pick someone without allergies, that's going to be 18 out of 39. And then to pick a second person with no allergies after we've already chosen one person with no allergies is going to be 21 out of 39. Okay. So now we can find the probability that they will both have allergies. So what's the chance the first person has allergies? 18 out of 40. What's the chance the second person has allergies? 17 out of 39. We can put that in our calculator. 18 out of 40 times 17 out of 39 gives us 196. So there's about a 20% chance that 2 randomly selected people will both have allergies. Now, we've got our multiplication rule. This, unfortunately, is not exactly on your formula sheet, but that is okay because we can always derive it from there. So this is the formula that we're going to see. The probability, well, not this one, or close to this one. The probability of A and B is equal to the probability of A times the probability of B given A. Okay? So the probability that both events, A and B, occur is given by multiplying the probability of A by the probability of B, given that A has already happened. We saw that right here when we did the previous example with the allergies. Okay? In general, this is our formula. When our events are independent, the probability of B, given that A has happened, is just the probability of B. It's just the idea of conditional probabilities. So you can simplify as just multiplying the 2 probabilities together, and that would be fine. So for example, in baseball, a perfect game is when a pitcher doesn't allow any hitters to reach base in all 9 innings. Historically, they throw a perfect inning about 40% of the time. So to throw a perfect game, they need to have met 9 perfect innings in a row. What is the probability that they do this, assuming that it's independent of his performance in other innings? Which isn't very likely, but that's okay. So to figure this out, since they're independent, we would just multiply the probability of having a successful perfect inning, which is 0.4, by itself 9 times, which ends up being a value, a very small value, of 0.000262, which makes sense. It's not very likely to happen. So, more about our multiplication rule. The general multiplication rule is given there. We rearrange it to get the conditional probability formula. Conditional probability is the chance that something happens given that something else has happened. So that's just going to be the probability of A and B divided by the probability of B. This is the one that's actually on the formula sheet. So when you're working this problem on the AP test, you have to show your work, including the numerator and the denominator. Do not just give the decimal probability as your answer. Okay? So let's go through an example. What is the probability that a randomly selected household with a landline also has a cell phone? So what this is saying is we want to know, I'm going to write it out in symbols, what is the probability that they have a cell phone given that they also have a landline? Okay? So if I'm using the formula that's on the formula sheet, I figure out the probability that you have a cell phone and a landline, and then that gets divided by the probability that you just have a landline. Okay, so looking at my table, cell phone with landline is 0.6, and the probability you just have a landline is 0.78. So I just put that in my calculator, 0.6 divided by 0.78, and I get 0.769. So there's about a 77% chance that you have a cell phone given that you also have a landline. Okay, let's look at one more example. This is going off of the example we already did with the cell phone or the media usage. We want to know what percent of students with good grades are heavy users of media. So what percent of students with good grades are heavy users of media? So what is the probability that you're a heavy user given that you have good grades? Okay, let's go for our formula. So on the top, we have what's the probability that you are a heavy user and you have good grades? And then in your denominator, just the probability of having good grades. Okay, if we look back at our data from the previous page, the probability that you are a heavy user and you have good grades, so heavy user and good grades, that was 0.1092. And then the probability that you have good grades, well, that's what we figured out in that problem, which was 0.6566. And then we just divide them, and we get 16.63%. Alright, what I'm going to do now is I'm going to stop this video. I'm going to show you all the answers for the next couple of examples. I want you to try them on your own though, and then the next video will walk you through how you get them. So at this point you want to stop your video, go through your answers, or go through the next examples and see what you can get. Once you have done those, come back to this last minute of the video and I'll just show you the answer. If you need to see them worked out, you'll watch the next video. Alright, so at this point you should have worked through the next example about the drug testing. So there's the answers for those. This one was a little bit of a trick question to see how you did on that. This one about playing sports here. And then this one about false positives is there. Okay. And then there is one more example. I think we are doing that as a class though. So stay tuned for the next video if you need to see these worked out.